Hey, Myers Mathematics. This is Kyle. Let's just jump right into it. So, how to use the quotient rule, right? So, what's the quotient rule? If you don't know what that is yet, you're taking the class yet, it's low. This is the way I remember it, at least. Low D high minus high D low. Okay, so what that means is if you're taking a derivative, right? So d dx, meaning take the derivative of something, right? Some sort of function. Then it's going to be something over something, right? The high over the low, the numerator over the denominator, to use the fancy math terms. But this is how you do it, right? So this is how you remember it. Low d high minus high d low over low low or low squared. Like low 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 la. Low d high minus high d low over low low. Okay, so how does it work? Well, let's say we've got a function, and the function is e to the x over x squared plus 1. Right, so something like that. So if we want to take the derivative, it'd be kind of hard to do that just on its own, right? We could actually alter it and then just use the product rule. I'll show you that in a second. But it would probably be easier to just use the magic formula. Low d high minus high d low over low low. So let's do it. Low. All right, so low. And then d high. So d high meaning I'm going to take the derivative of the high part. So d high, low d high, I'm going to take the derivative of e to the x. Well, that's just e to the x. Right, good so far. Minus, minus. And then high, so the high, which is also e to the x, d low. So d low. Derivative of the low, derivative of x squared is 2x and then plus 0, right? Because all constants go to 0. Derivative of 1 is 0. So that goes like that. And then it's all over low, low. So the low was x squared plus 1. So it's x squared plus 1 times x squared plus 1, or I can just say it's squared. Right, so either way, that's why sometimes people will remember the formula as over low squared, but low low kind of rolls off your tongue. So it's a little easy to remember. Okay, so let's clean this up a little bit, but basically we're done. The rest of this is just the algebra. So I've got 2 e to the x's. I can actually just factor out an e to the x and make it a little bit easier to look at. If I factor out e to the x, it's kind of like I'm dividing it from both. So this would be x squared plus 1 minus 2x. All right, over x squared plus 1 squared. So I can factor the thing that's in parentheses. It'd be x minus 1 quantity squared, but that doesn't really help me because it doesn't cancel with anything in the denominator. So I'm just going to leave it like that. There's not really much else I can do. After you factor out the top a little bit and clean it up, you can kind of just tell if you're going to be able to go any further and cancel stuff. If you can't cancel anything, there's really no point in making it look really, really pretty. Unless, of course, your instructor wants you to make it look pretty. Now, there's a little bit of a cheat method for this. So if you prefer product rule, which is left derivative of right plus right derivative of left, right? Where if you have d dx of two things that are multiplied, right? So if you have two things that are multiplied, you can use a product rule, and I'll probably have another video for that another time. But basically, you could turn a quotient rule into a product rule. So I'm not going to show you the math behind it, but basically all I need to do is write e to the x, And then in order to bring the denominator up to the numerator, I just make the power negative, or negate the power. If it was already negative, I could make it positive, but just call it -1. And now I can take the derivative of the left and the right and use the product rule instead. So if you're on a question where it asks you to just take the derivative and you prefer to use product rule, you can actually just use product rule instead of quotient rule. All right, but let's do one more example just to kind of solidify what's going on here. So let's say we have sine x over 2x cubed minus x. All right, just kind of throwing out some random stuff there. And again, you can use product rule if you bring the bottom up, but I'm not going to do that. I'm going to just do the quotient rule. So it's low d high minus high d low over low, or low squared. Low d high minus high d low. All right, so low, right, low d high, so derivative of the high, here's high. Derivative of sine is cosine. Oop. Cosine. Okay. Low d high minus high. All right, so high d low, so derivative of 2x cubed is going to be 6x squared, and then derivative of x is just 1, so minus 1. So low d high minus high d low over low squared, or low. 2x cubed minus x, low squared. Okay, cool. Let's, can I even clean this up? I might be able to clean it up a little bit, maybe, I don't know. Let's see. No, it doesn't really look like it, because one of them is multiplied by cosine, the other one by sine. So there's not really a whole lot I can do. And then once I took the derivative, I didn't have anything with at least one x in it, right? Because over here, that's going to be 1 times sine, so that's just going to be a sine value. So it really doesn't look like I can clean this up at all. I can't really get anything that'll cancel with the bottom. So this is basically it. You could distribute the sine and the cosine if you really wanted to, but that's pretty much it. That's the derivative. And I would just call that a day. All right, so that's how you use the quotient rule. And again, you can use the product rule and change it if you like. But hey, so I have a guide to not missing a math problem. It's on my website, Myers Mathematics. Go check it out. It's a free PDF, kind of a little guide on how to not miss a math problem, the 5 mistakes everyone makes, and how to avoid them. It's for free download on my website, Myers Mathematics. I hope you find it helpful. And of course, if you find this video helpful, give it a like and a subscribe.